Great, so welcome to this quantitative methods video. So what we're looking at here is the sum of a geometric sequence and how to reduce that to a simple expression. The reason for that is this is used all over the place in finance, in the CFA curriculum and elsewhere. And in finance, often you're looking at a series of future cash flows and discounting them back to the present. And a lot of models will simplify that by turning that future set of cash flows into a geometric sequence, which can then be reduced to a simple expression. Hence why this useful tool exists and why we use it quite often. So I thought I'd make a specific video just to derive how we get to the simple expressions, so that when you then use them in quantitative methods or in any of the valuation modules, then you'll understand where the formula comes from. Okay, so first we'll take a geometric series. So here the series is the sum of the sequence. Here the series, we'll call it 1 plus d squared plus d cubed and so on up to d infinity, where the modulus of d is less than 1, which would mean the sum is less than infinity. We just label that sum or the series as S, and if you were to multiply that series by d, you would get the expression that ds equals d plus d squared plus d cubed plus d to the 4, so on, which of course is just the same as s minus 1 over here. So if you take the left hand expression and the right hand expression, we get to d times the sum equals the sum minus 1. So starting with that, d times the sum equals sum minus 1. Just rearranging it, you have 1 is equal to s minus d times s. Take out the factor of s, so 1 equals s times 1 minus d. And therefore, if you divide both sides by 1 minus d, you then get that the sum is equal to 1 over 1 minus d. So if you want to look at the sum of a geometric sequence where the modulus of the first term is less than 1, then that sum is equal to 1 over 1 minus d. This is a very useful expression in all sorts of valuation situations.